Hello everyone, thank you so much for being here. My name is Bibek Paudel, and today we are going to be taking a look at how we can optimize urban traffic for both pedestrians and vehicles. Let's start by talking about urbanization. Urbanization has been steadily increasing over the years, and it is projected that by 2030, 60% of the world population will be living in urban areas. And to deal with increasing urbanization, our traffic control systems have evolved from manual and fixed time control to smart and intelligent controls such as using computer vision algorithms. And at the forefront of this research lies reinforcement learning. However, most of the existing reinforcement learning research has been focused about optimizing the outcomes for vehicles, whereas as urbanization increases, the conflicts and interchanges between both vehicles and pedestrians increase. So there's clearly a need to be able to optimize for both the stakeholders. And that's exactly what we do in this research. So to be able to do that, we take this environment, which is a real world environment from University of North Carolina. And this environment has one intersection at the end and then several crosswalks spread across the mid block. And we have a real world data that is of 200 vehicles per hour and something like 2000 pedestrians per hour. And the goal here is to use reinforcement learning to simultaneously reduce the wait time for both pedestrians and vehicles in this environment. Now let's look at the markup decision process, starting with the state. Our state consists of the phase vector of the entire corridor and the information about the intersection split into pedestrian and vehicles, and the information about both pedestrians and vehicles in the mid-block crosswalks as well. For the action, our agent's actions are split into the action for the intersection, which consists of 4 different options, and for actions for each mid-block, which consist of 2 different options. For the reward function, we use an existing reward function called maximum weight aggregated queue, and then we modify it to normalize it first and then exponentiate it afterwards. Now what this does is if the queue length of pedestrians or vehicles is increasing, or if the maximum wait time experienced by the pedestrians and vehicles in that queue is increasing, the penalty experienced by the agent increases exponentially. And the same thing happens for both pedestrians and vehicles. Now let's look at the results. So when fixed time traffic signal control is applied to the signals in the corridor, we see that the delay experienced by pedestrians is something like 6 seconds, and the delay experienced by vehicles is about 35 seconds. Now, when we remove all signalization from those crosswalks, we see that pedestrian wait time is reduced 60% and vehicle wait time is reduced 40%. However, when there are no signals present, that means there's a high number of conflicts between pedestrians and vehicles as they decide which one should get the right of way and which one should cross first. So what we do here is we take the same setup as the fixed time signal, but instead of the fixed time signal, our reinforcement learning agent is controlling that corridor. So in that case, we can achieve the performance that is similar to unsignalized, but we have no conflicts. And the reason we have no conflicts here is that we have a dedicated phase for vehicles and pedestrians to cross. We took our results one step further and analyzed the behavior of the agent to be able to tell why it performs better. And the first thing we found is that the agent is able to coordinate multiple signals at a time, although we did not program such a behavior. We can see that during the course of its training, the number of signals that simultaneously turned green increase over time. Similarly, we can see that the agent is also adaptive, as in based on the level of demand that it faces, it changes its switching frequency high or low. So in summary, we were able to create a reinforcement learning agent that can simultaneously reduce wait times for both pedestrians and vehicles. If you have any questions, please feel free to send me an email at this address. Thank you so much.